I'm Curtis Brown from TI, and I'm here with my friend Dr. Jones. I'm super excited for another Smart Space video with you, Dr. Jones. Hey, I was just thinking the other day, we talked a little bit about what a ratio is and what a ratio does, right?
Yes, we
So
did. That was fun.
what about using some ratios in maybe some real world context? I know we had that great fruit salad that we talked about, which was really awesome, a great way for us to be able to describe what a ratio is and does.
Yeah.
But now let's see if we can put some ratios to use.
Okay.
As a matter of fact, can I share my screen? I'm going to show you
Of course.
something. I'm going to show you something on my screen here that my son was asking me about. Okay.
Is this another visual example?
He's
Because
doing
I
an art
love the
project.
visuals. Oh, this is perfect. I love
Yeah.
it.
My son is doing an art project and he is wanting to make some orange paint, right?
Okay.
So he's thinking, okay, yeah, I can mix red and yellow paint. But he was trying to figure out what ratio to mix his red and yellow paint at so that he could get maybe a slightly more red version of the orange. So he wants to kind of be closer to the red side of orange. And so I came up with two different ratios of red to orange, red to yellow to help him maybe make a decision.
Okay, so you have like a set table on one side with that one ratio and then one on the other, correct?
Right. That's exactly right. So I have one set here, which is a ratio of 1 to 3. So one red can for every 3 yellow cans. And I've got a bunch of different versions of that.
Okay. Those are all equivalent.
Show you a whole bunch of different versions of that, right?
Okay.
So if he ends up needing lots of paint, we could do 3 cans of red to 9 cans of yellow and this. So this is one set of equivalent ratios, or one color really is ultimately what this would be. Now the other side, I've got this set that is 2 red cans for every 5 yellow cans of paint. So this is a different color of orange, okay? But my question to you, and really his question was like, which one is gonna be more red?
Okay, so you're trying to figure out
his is more red.
You're trying to figure out, just looking at those two things, looking at all the different versions of the ratios, which one will give you the most optimal orange that has more red paint than yellow paint?
Yeah, they want one that's going to be more red than yellow paint. So we were talking about different ways we could come up with comparing these ones. And he actually helped me out with a couple of different ideas. He said, hey, Dad, you notice if you look at those two tables, he said, look at the bottom of that first table. He said, hey, look, you have in that bottom of that first table, you have 6 cans of red paint.
Yes.
And you have 18 cans of yellow paint. You notice, Dad, that you also have a place where you have 6 cans of red paint on the right-hand side. So he said, hey, what if we compare equivalent amounts of red paint to how much yellow you're going to mix in? And so we started looking at this, and I noticed that 8 cans of yellow paint to 6 cans of red on the left-hand side, and I have 6 cans of red to 15 yellows on the right-hand side. There's less yellow to the same amount of red. So the one on the right seems like it's probably going to be a little bit more red in tone than the left.
Can you check that? Because it's always good to have more than one method.
Definitely a good way to have more than one method. Well, that was what I came up with. But my son said, hey, but I also noticed that you've got one space where you have the same number of yellow cans, and we could compare the reds. So now I have yellow cans in both cases, right? And look at what it is. There's definitely less red, right? So I have 6 cans of red paint on the right-hand side and only 5 cans of red paint on the left-hand side. So totally a great way for him he's like, yes, this totally makes sense.
Yeah, I like that one because you can totally see, looking at the 15 and 15, that there are more red on the right-hand side. It's very clear. I like that way.
It's very clear.
What? So, look, you can also look at look on the left-hand side on the very top, how it says 1 to 3. So there's 1 red can and then 3 yellow cans, right?
Yeah.
So this is almost like a unit. This is like a unit rate. Like for every 1 red can, there's a certain number of yellow cans, right?
So how can we do the unit rate for this one?
Okay, So we don't have any ones there, but we can still figure out the unit rate. So if you look where the 2 is, so to get to 1, we just divide it by 2. So if we divide the other side by 2, 5 divided by 2 is like 2.5. So the unit rate for the right-hand side will be for every 1 can of red paint, there are 2.5 cans of yellow paint. So really, there's less yellow paint on the right-hand side than there is on the left-hand side.
That's right.
To 1 can of red paint. That's another way of looking at it with unit rate.
Well, hey, Dr. Jones, thank you so much for giving me an idea there about how to help my son using these unit rates to be able to talk about this. We came up with 3 great ways to compare the amount of red paint to the amount of yellow paint in this project. And so, but I'm going to stop sharing my screen because I know you had some other things we needed to talk about in this video you wanted to share. So let me stop sharing and we can chat a little bit about that stuff.
Yeah, I love that example. That was great. Now I'm going to get some batteries because my calculator died. So I want to get some batteries because we need some batteries. We need some calculations for this one. So let me get this. You know, I bought a lot of these because I have a lot of calculators and they're all AAA batteries.
Yeah.
And, you know, they go in these kind of calculators. But I got a deal. So I got like.
You got a deal?
Yeah, I got like 4. They come in packets of 4.
Uh-huh.
And I got them for each for $3.99, which is great because that's a deal.
Wait a minute. How much did you spend?
So for each packet of 4 AAA batteries, it was only $3.99. So I got 16. I needed 16 of them because each calculator that I have takes 4 AAA batteries, and I have 4 calculators, so it worked out great.
So that's like $15.96, right?
Yeah, $15.96.
Okay. So why'd you do that? Because for a 20-pack, you can spend $15.99, like a 20-pack of batteries.
See, I don't need 20 batteries. I got the better deal. I only need 16 and have 4 calculators, so it's cheaper. $15.96 is cheaper. So.
Well, yeah, okay.
Look,
save 3 cents.
I'm gonna prove my point, but I'm gonna use unit rate. We just finished talking about unit rate using my method, right? So we're gonna do unit rate. I have my. I already got ready because I knew you were gonna say something. And I'm gonna show you.
Okay.
I'm gonna show you.
Well, show me, but I don't believe you.
Okay, watch. Okay. So I spent $3.99, right?
Right. Uh-huh.
I know this is off topic, but we're gonna do this. Okay.
That's fine. That's fine. We'll get to the other examples here in a minute. Okay, so $3.99 divided by 4. Okay,
yeah.
so we're gonna get that to the unit rate.
Yeah, this is my 4 batteries.
Okay.
$3.99. We're gonna figure out the unit rate. So the denominator needs to be 1. Okay, right. The denominator needs to be 1 because that makes it 1 unit. And then we can figure out the price for 1 battery in this package of 4 batteries.
Okay.
So I'm going to divide the top and the bottom by 4, which is the same thing as like dividing by 1. So I'm not really changing.
We're just scaling it, really. Yeah. Like you're basically evaluating $3.99 divided by 4, right?
Exactly. That's all that I'm doing. That's really it. But, you know, mathematically, it's good to have, you know, the visual.
Okay.
So the denominator is 1 unit. And
1 battery, right? It's 1 battery.
1 battery.
Right? We're getting the price per battery. Okay.
Yes. So when I divide 4 into $3.99, that's like almost $4, right? So it's really like about $1.
It's like 99.75 cents. If you really, So it's like really.
So it's like $1 per battery.
Yeah.
That makes sense. Okay.
I can go with that.
So how much did you say your 20 pack was?
Well, my 20 pack that I was trying to recommend to you is $15.99.
$15.99.
$15.99 for 20 batteries. $15.99 for 20 batteries. Now I know that's 3 cents more than what you spent for your 16 batteries, but
exactly. Okay, so let's pick out the unit rate.
Think about this.
We're gonna do the unit rate the same way.
Sure.
So I want the denominator to be 1, so I can get the 1 battery. So I'm gonna, find the equivalency, and I'm gonna divide. So I'm really dividing the top by 20, but we do on the top and the bottom, but 1 unit. I'll have a 1 in the denominator, and I need to borrow your calculator because mine is dead.
So here, let me hand you my calculator. Here, I got it.
Oh, thank you. Perfect. Perfect. Got it. Okay, so when I put this in, okay.
It's 79.95
Yeah,
cents, right?
you know,
So 80
yeah,
cents a calculator,
90s,
80 cents a battery. Yeah.
Yeah.
Okay.
You know, I saw it. That's why I was pausing. 80 cents for each battery. Okay, so, all right, so you had the better deal. Okay, so yes, if I had gotten the batteries, I would have saved money. You're right, because it's 80 cents for each battery with your deal and $1 per battery with my deal. So yeah, 80 cents per one battery is a better rate than $1 per one battery. So you had the better deal.
Do me a favor. Do me a favor real quick. How much better a deal was it? I want to find out. Can you,
want to rub it in. You want to rub it in.
Can you do me a favor? Do me a favor real quick and just you know, at 80 cents per battery, let's find out, you know, just how much would it have cost for your 16 batteries?
Okay. So 80 cents times the 16 batteries.
So 80 cents a battery times the 16 batteries. How much would that have been? Okay. I was just wondering.
$12.80.
Yeah. Just wondering.
Okay, so I missed out on a $3. Yeah, I could have saved $3. Okay, but the fact of the matter is, I have batteries for my calculator now.
That's true. That's true.
Okay. This is crazy because my examples are this is finding the better buy. You know how you can use unit rate to find the better buy. Now my calculations are actually good there. So you want to see the video anyway?
I do. I think that would really be kind of a cool idea. So this was a great example. This was a fun one. But I'd love to see your video on unit rate and seeing that a little bit more.
Great. Okay, I'm gonna share my screen.
All right.
Dr. Jones here again. And now we're gonna talk about determining the better buy. I absolutely love this concept because it really shows how ratios and rates are connected. Now we all know about ratios, but rates are great as well. Rates are ratios that have different units. So let's look at an example and let's play with a little bit and kind of see how rates and ratios are really connected together and they can help you figure out the better buy. This is important because this way you will never get gypped when you're trying to figure out what's the better deal when you're buying things. Okay, so let's say we're given 20 brownies and each brownie is 40 cents each. We want to buy the whole quantity of 20 brownies and we know there are 40 cents each. It's a pretty good deal, especially if they're the nice gooey brownies, because brownies are my absolute favorite dessert. Next, let's say that we're comparing it with another deal. The second deal we have is 20 brownies, but you get the whole batch of 20 brownies for $10. The whole entire batch for $10. And you're trying to figure out which one is the better buy. Is the better buy getting all 20 brownies for $10, or is the better buy getting all 20 brownies for 40 cents each? The cool thing about this is it's a rate because we have 20 brownies and we have 40 cents or $10. So our units are brownies and dollars. So we have two different units we're comparing, which makes it a rate. But which rate is better? Which ratio is better? Which deal is better? Well, that's where math comes in. Okay, so we really want to figure out what is the better deal. They both look pretty great, but what I notice is that they're expressed in two different units. Well, that means that they're rates. Rates are ratios expressed in two different units. And so over here, we have 20 brownies that are each 40 cents. And over here, we have 20 brownies that altogether will cost us $10. Something a little bit off. Well, to solve this, If we were to express both as a unit rate, we could compare the quantities and really see which is a better deal, because they both look pretty great. They both look pretty good. All right, so let's do some calculations. Over here, we already know what each brownie is worth. It tells us. It says that each brownie is 40 cents each. But over here, we have to do some calculations to figure out how much each brownie is worth in this group of 20 brownies. Well, we're gonna set up our rate as a fraction, because ratios can be set up that way. The numerator is going to be our amount of money, which is $10 in this case. In our denominator, we're gonna put our total quantity of brownies, which is 20. So we have $10 over 20. And that reduces to 1 over 2. And 1/2 is the same thing as 0.5 or 50 cents, which means over here, each brownie in that batch is 50 cents each. So each brownie over here is 40 cents, and each brownie over here is 50 cents. This is obviously the better buy. This is the better deal, because over here, we're having a cheaper amount per brownie than over here. And we figure that out by finding the unit rate and then comparing the unit rate quantities. Unit rate is fabulous. It helps us figure out so many different problems. In fact, let's change this up a little bit. Let's just change them up a little bit. Okay, so it's changed up a little bit. If you notice, now there's a shipping fee. Over here, we still have our 20 brownies for 40 cents each, but there's a shipping fee of $5. And over here, we still have our 20 brownies that are $10 in total, but the shipping fee is cheaper. It's $3. So which one is really the better buy? Let's figure it out. So we already know that over here, we know the unit rate. We calculated it out just a few minutes ago. So the unit rate over here is that there are 20 brownies and each brownie is 50 cents each. When we have both of our unit rates, 40 cents each, 50 cents each, we can calculate how much money we're spending in total with these rates, okay? So over here, if I have 20 brownies at 40 cents each, I'm doing 20 times 4/10, and I'm going to get $8. So it's really $8. And we know over here it's $10. We figured that out already. So when I'm figuring out how much that's going to be with the shipping cost, over here I have $8 plus the $5 shipping cost. So that's $13. I wonder if it's still the better buy. Let's figure it out. Over here, I know that it's $10, and $10 plus the shipping cost of $3 is $13. So you guys, there isn't a better buy. They're both equal. Who would have thought? Let's look at one more example using these brownies. Okay, so our problem has changed just a little bit. Over here, we have 10 brownies for 40 cents each and a $5 shipping fee. And over here, we have 10 brownies that you can get all together for $5 with a $3 shipping fee. Let's figure out which is the better buy in this situation. So this one is already written as a unit rate. We need to write this one as a unit rate. So 10 brownies for $5 in total. Well, we're gonna take that and we're gonna do the same thing we did before. We're gonna put the $5 over the total of 10 brownies, and our unit rate is still going to be 1/2 or 50 cents. So really, this will give us that for 10 brownies, we're really paying 50 cents each. Very similar to our first examples. So 40 cents each, 50 cents each. Okay, so now we're gonna take our unit rate and we're gonna calculate how much money that is per brownie in total. So 40 cents each times the 10 brownies gives us $4. And 50 cents each times the 10 brownies gives us $5. Now it's time to put those shipping fees together. $4 plus the $5 shipping fee is $9 in total for this purchase. And $5 plus the $3 shipping fee is $8 for the grand total. $9, $8. In this case, this is the better buy. Using rates is a great way to compare quantities, figure out the best deals, and unit rate is a great way of breaking it down all together. Another fun way of looking at ratios, especially in the real world. See you next time.
Wow, so that was a really great video. Thanks for all that information, unit rates, and all those great examples. This is such a cool problem. This was really a fun video to put together.
See, I told you I knew what I was talking about, though. So
yeah, I know. I was just giving you a hard time. On that one.
But, it's great because sometimes, as educators, we think more about our problems we do in our classroom and not think about how we use this math all the time in our daily lives. So
that's right. We definitely use this. Well, that's it for this particular Smart Space video. I'm super excited to do the next one with you. All right, we'll see you next time.